This is a new topic we added to the agenda. I'm going to discuss the client configuration server. It's a component that makes the TV server manage clients better than any competition we know of. So the stuff I'm going to cover defines what we mean by client configuration. I'll walk through some ways of using it, discuss the components in our product, and then walk through end-to-end the process of the client and server communicating with each other for new configurations. When we talk about managing clients, we mean that we have to take care of establishing and maintaining connectivity between the clients and servers. Bart talked a lot about that, and Bart also talked a lot about authentication and authorization. We do call those management to some extent, because the process of defining who gets what level of service and how to connect and managing what they connect to. So that's what all that involves. Monitoring, Jim will talk about in the next presentation. That means really getting a read on log instrumentation and figuring out how the server is performing. Logging is the stream of data that goes into the data warehouse Joy talked about. All of that really does give you a lot of tools for managing TV server, especially the logging. It's interesting to focus on that for a second. That all the load on servers generates logs, and NetApp can define what those logs are by going to the data warehouse at a single place to slice and dice the information about which servers were the most heavily loaded, which zip codes are giving rise to traffic of a certain type. They can manage network topologies and even do troubleshooting based on that kind of information. So all of those are management tools. The last one on the list is what this presentation covers: managing client configuration, defining how each client box is set up and what software is on each box. So we have a number of components in TV server that allow clients to update themselves over the network. Set-top box comes up for the first time. From that point on, you can manage the version of the operating system, configuration settings, other applications that are on the set-top, and actually there's a list right here, including the first-time setup. We have an endearing concept called the brain-dead box. First time a box comes alive with bolts on it, it doesn't know anything about its configuration, who it belongs to, what network it's supposed to connect to. So the client configuration server's job is to recognize that box for the first time and give it a set of instructions to set itself up for first-time operation. After it's in operation, we can dynamically update the operating system at any point in time. So when there are upgrades that allows the network operator to move with the state of the art, to bring out new features, new versions of operating system, don't have to do truck roll or change boxes to update Microsoft TV. Settings are what you think of in a registry. The registry is the configuration system of Windows, and the client box is based on Windows CE, has a registry. So our server has a way of changing settings in the registry on all of our set-top boxes. That might include things like the default URL for service. If the box comes up, it doesn't know who to contact, we can hardwire always go to a well-known place that we know is alive. So that's an example of one setting that can be managed and changed on the set-top for reliable operation. The electronic program guide data Suresh talked about is an example of data the client needs to be told about. Our server tells the client, here are the listings that apply to you for your zip code. Here are the listings that are applicable to the services you've signed up for. Does HBO show up in your listings or not? Things like that. So the server knows about all the settings that apply to the client. This is the system that gets the right listings to the client. New applications might include in the future things like games or any imaginable application on the client. Executable code that needs to be downloaded is included in that feature of client configuration system. And then finally, the logs we talked about. Logs generated on the client, files containing a lot of information about clickstream, channel tuning information, crash logs for troubleshooting. Those are all files on the client. The client configuration server tells the client where to upload those on the service, so it can make their way to the data warehouse. The components of the system are on both the client and the server. On the client, there's a piece called the Client Configuration Agent, CCA, and the job of that component is to speak with a server component called the Client Configuration Server. And actually, they just speak HTTP to each other, and the responses are in the form of JavaScripts, for what it's worth. So the point is there is a client component and a server component that have to work together for the system. I'm going to go through the details now of what that communication is like between the client and the server. On the client, the first thing that happens is that in bootROM, there is a step that causes a client configuration agent to load during the boot process on the setup. The OS begins to load and calls this loadable agent. The point of it being a loadable agent is that it's possible for OEMs, the people who make set-top boxes, to replace that agent, if they want, with any other agent that's capable of going to get downloads from other sources. So, for example, if General Instruments has an operating system download agent that goes to some GI-specific place to get its OS, it's easy for them to replace our CCA with the GI download agent, and the set-top continues to boot and work the way that it's supposed to. It's also possible for GI to modify their OS download agent into a hybrid of the GI downloader and our CCA. So you get benefits of the in-place existing GI download infrastructure and all the new features we provide, like the ability to upload logs and receive instructions about downloading executable of any kind.
Can we give them source to do that, or how does it work?
Yeah, there's a full set of documentation about CCA and the interfaces between it and the outside world. So the agent's job is check for possible download or configuration changes, and if there are none, if there's no work for him to do, he returns to the boot arm and the set-top box just loads and works. If there is work for him to do, the agent uses some network-specific communications infrastructure to work over whatever the network is, speak to client configuration server. So the point about network-specific driver here and network-specific driver here is that CCA and CCS are designed to work together no matter what network infrastructure is. By changing a driver in the set-top and having the corresponding driver on the server, this could be, you know, as per an earlier question, it could be a telco network or cable, DSL, satellite. It's a pluggable component of the system. Okay, so here we have the client requesting instructions from the server. The server receives the request and then checks the client's state. In the post that got from the client says, here are all the packages of data I currently have, is the version of the operating system, the CPU type, and any other interesting information. The server then responds with configuration instructions. He looks in the database, finds out all the settings that are supposed to be applied to that client. Is he update? Are there some deltas to be applied? And responds with a script that will upload back to the client to the next slide. These are actually the words that wrap around what I just said, so I'll skip through that. Okay, so we had the client requesting instructions. This is the response. The server sends a configuration script to the client. Again, it goes over any network. The agent on the client receives the script and processes it. The effect of processing it is the agent has to go and download an operating system from some OEM's website and game scores from game vendor's website, the example. So the thing we can't see here is point 3. It's the processing of the script. The script said go and do these things. So the client configuration agent visits the internet. It goes to the OEM. This might be GI, Philips, or Compaq, wherever. Gets the OS image, downloads it, installs the OS image, reboots, and the setup is now in business with the new operating system. Likewise, the client visits the network, gets scores from the game vendor, and now the game has been updated. So that's the process of requesting instructions, server sends a script, and the client goes and visits the network to do what the script said. Well, again, these are the words wrapped around that slide. The server provides commands. The client can do all sorts of interesting things like deleting old files, creating partitions, changing the layout of the disk, and so on. And the client is responsible for going to visit URLs. I'm going to discuss in 2 or 3 slides' time how this works in a broadcast network where the client is not actually connected to the server. We do handle that situation, and I'll discuss that in a few slides. Before I do, I just want to go through how easy it is to set up this process for the operator. There's a process called administering CCS. An operator creates packages, which are all the commands and URLs, the pointers to the data that it has to make it to clients. The package is embedded inside a channel. The channel is actually a word that derives from channel definition format, CDF. That's a World Wide Web Consortium standard. We follow that standard. They use the word channel to mean what is the package and where does it have to go. The targeting information includes the schedule, when that package is sent out. They want the whole world to upgrade their OS on, say, at 12 o'clock. So people in one zone will do it at 12, and those zip code can do it at 2 in the afternoon, etc. There's a schedule. There are dependencies, like update this driver if you have this version of the operating system. If you have a different version, then you do something else. That's what dependencies means. That's the standard. The third thing the operator has to define is groups. Groups just means bunches of clients. That's the subscriber management database, or our service database defines who the population set-top boxes, who they are, who is the population. Who is the population is defined in the database. Creating groups means all the users in a particular zip code, Phillips boxes, might be an example of a group. All the people who have subscribed to this game application and get expensive, additional services. Define the groups of users. Then finally, the fourth step is to say, out of all the packages we know about have to get to people and the channels that define when they have to get to people, we'll subscribe channels to groups. So that's making the connection between the available information and who really gets the information. Now CCS is set. Define the data, when it goes, and who gets it.
Subscribe channels to client.
Yeah, define subscribe channel client groups. Group is a word that's used throughout the CCS documentation and appears in the UI. So there is actually a drag-drop link between those two. It's pretty straightforward. Okay, and for the lucky people who have PowerPoint and are reading this online, all the words that I just said are pretty much on the slide. Now we're going to talk about data broadcasting. What happens when the client sitting out here at some far end of the network is not connected to CCS? It's not going to post its status and say, tell me what to do now. Hanging off a satellite dish, and it just wants to receive its instruction passively. So we support that, and we call it data broadcasting support. The end-to-end example of what might use that is the EPG. So when Suresh talked about his EPG server in Microsoft TV Server, he mentioned that it has this export pipeline that allows the operator to create EPG listings. There might be short listings for present and following information. There may be slightly larger program listings for 6 hours worth of programming and stuff that covers 7 days worth of programming. So those are each different files. Each of those types of listing is represented by a file. There might be versions of those files for different languages and different zip codes and full. So EPG listings are actually a whole bunch of files. They were derived from information supplied by a third party. This is third-party data sources. EPG listing provider is the example of a source. Send data to Suresh's database. We slice and dice that into create these files called listings that have to be sent to clients. So Suresh server, the EG server, calls the client configuration server and creates a channel called EPG listing files. It says what's the breakdown of groups of people who are supposed to get those listing files. So in a very standard way, it just uses the interfaces described in the previous couple of slides, and he sets up CCS to know about these files that have different types of users. Then we have a component called the broadcast agent who is going to pretend to be a client to CCS. He queries CCS and says, tell me about all the files clients are supposed to have. So it's exactly the same mechanism we had in the previous slides where the clients were posting their status and saying, tell me the files I'm supposed to download. He says, tell me the files that all people are supposed to have. And CCS responds with a script that says, it's actually just an embedded conditional script that says, for this type of client, here's all the stuff he's supposed to have. For this type of client, given this version of the OS, tell him to go and get all these things. There's one huge script. The broadcast agent then goes off and visits the internet, goes to URL, scrapes together all the files just like the client would have had to do for himself in the previous few slides. Now he's got a bunch of files ready to be broadcast. He knows the schedule for when they have to be sent out because CCS told him the schedule as part of the script. So he now calls an API on a third-party piece of equipment. Part of the head end is a data broadcaster box. It might be a GI OM1000 or box by SkyStream or Divicom and others. They know how to do MPEG transport stream, IP encapsulation, BBI, or whatever type of data transmission it is to their network over the network and it reaches the client. A little more detail in the next slide. Actually, it looks like a lot more detail. It's actually a similar story. It shows CCS, and over here is the client. So it's the same end-to-end story where the broadcast agent queries the server for instructions. The server provides a comprehensive script for all clients. The agent then connects to the data providers. He does what the did in the first slide I showed you, this diagram. And then he schedules this data for transmission. Examples are a carousel model, where the schedule says send it over and over, send it every hour. A daily bulk transfer might be an operating system image. It's a large image, and you want to make sure the whole file gets there as quickly as possible and use all the bandwidth you have, get it to the client. But we're not going to use all the bandwidth we have all the time, so do it daily. That's an example of a bulk transfer. A trickle stream might be data that's sent out all the time using low bandwidth, and we'd even call that opportunistic transmission. It doesn't really matter if the sports score didn't make it round this time, because in 2 minutes' time it will be updated again anyway. So that's a characteristic of data transmission we know about because CCS sent that in his script. And so finally, the broadcast agent calls an API on the broadcaster with instructions to transport files for broadcast as scheduled. Examples are SkyStream, Comcast, GI, and others. So now we leave TV server land and we call this API. The API has to be implemented on a third-party piece of software that receives the instructions, fires up the Divicom gear or the SkyStream gear, starts streaming it the files, and the gear knows how to do MPEG transport stream, DSSCC, BBI, DOCSIS, or however the network is configured to get the data to the other end. The data beams out of the network. It's received by a client-side component that knows how to tune to the appropriate data channel, receive the data, and store whatever data it received on the client. So this is a component on a client that corresponds to the broadcast gear the network operator is using. It's a mini port driver that has to be developed within the Windows CE data broadcast services infrastructure. Finally, the agent uses the script to decide what data is relevant to him, executes the instructions, installs data, and does everything he would have done if he were real-time connected to the server. Okay, so the point of where we're at now is to say that the server has the ability to configure the client, all clients, in the way NetApp wants, and we can even do it in a one-way network called broadcasting. Server works with any broadcast network because we have this API that abstracts whatever the network is, and that means there's system integration required to implement that API on the front end of whoever the broadcast gear provider is. CCS can be customized. We even have two versions of it. We ship a version called the standalone version of CCS on the Microsoft TV disk. So when you buy our client, there is a CCS on that CD, which means that network operators can have a server from us on day one that knows how to update their operating systems and send files to clients without them needing all the TV server infrastructure. Of course, CCS is also integrated with Microsoft TV Server, so when you buy the full server, you get all the additional services you've heard about in the last 7 hours. The product has APIs for automating the processes we described, creating channels, telling it to stream data. Those interfaces are scriptable, so third parties can write VB scripts or command line tools, however they want to instruct the server to send files, even do that remotely. And finally, it has an architecture that allows us to plug in support for different types of client in the future. It's a feature of the architecture, and we'll be exposing that feature beyond the 1.0 time frame. So all this infrastructure I've described will be capable of supporting implementations of CCA on things like cell phones, PCs, other types of handheld devices or whatever, because we can implement different protocols within this architecture. I'll go very quickly through this slide, and then there really is only one slide left. For integrating CCS and CCA into the real world, the network operator needs to decide who's going to operate this client management infrastructure. Is the NetApp going to be responsible for defining packages and when to upgrade OS on set-top boxes? Or do they want a relationship with their OEM? Maybe GI is a manufacturer of the set-top box, and NetApp wants GI to be responsible for distributing OS updates. So who's going to do that dictates where does the server go and who manages the server. Or outsource it to some third party, and on and on. So there's the operational management, I guess, infrastructure is a thing that has to be defined. Whoever the answer was to that question is then responsible for creating packages, defining channels that contain those packages, and associating channels with groups of devices. It's possible to leverage the subscriber management database or outsource database to get that group information. So there's integration between TV server and the outside world. Security is really important because you don't want bad people sending bad software to set-top boxes in an unprotected way. So our infrastructure supports digital signing of the data that gets into a set-top box, which means the set-top is going to trust the source of the data. If the data comes from GI and the GI box, then there's going to be a GI signature on the operating system image, and the set-top will trust that operating system image and install it. If it comes from a non-recognized source, the client's just going to drop the bits and not install it. So implementing security, putting the right signatures in the box, making sure that the bits you want to download are signed is work. Finally, configuring the client, telling the client, who's your CCS? You know, if I'm going to Compaq to get my operating system image, then the client has to be configured to know that. It's just a URL burnt in RAM. It knows where to go. It needs public keys, which are the ways of unlocking these digital signatures. Who's the signature? Well, I know it comes from a trusted source because burned in RAM on my smart card is the key for encrypting that signature, so I know I can trust data. Okay? Configuring clients with this information has got nothing to do with the server. It's work that has to be done as part of creating an end-to-end infrastructure. Then the last bullet for the system integrator is that to make it easy for operation, write scripts that make it easy to just kick off the right job at the right time of day, register new images, and know who to associate those operating system images with. When EPG gets updated and you want to send, the example we heard earlier was the sport games running 5 minutes late. So you want to change the EPG to show the start time of the next show. You want to do that in real time. Well, there should be a script called update EPG now. Just run that script, which automatically goes to the right interface in the broadcast age, and the right file gets sent to clients. So to wrap up on all of that is that our platform, and I'm using the word platform here to mean including the client and the server to work end-to-end, makes it possible to support dynamic client requirements. The client can move and evolve and be upgraded over time. Continuously update client operating system, both downloading and uploading information. Uploading logs was the thing we talked about. Changing settings on the client, it may be specific to applications, what server it is this application uses its default, or who are the members of my game community that always their scores when I'm playing my game. That's a setting specific to a game. The game vendor has the opportunity to set things that are specific to his game in the client. It works over any kind of network, including one-way networks that are broadcast networks, and it can be customized to work with any-to-any, including any protocol, and it can be automated through scripting. So that was a Swift version of the CCS architecture. Questions? Thank you. Thank you. You're done.